Hello everyone, my name is Virendra Pratap. I am a maths teacher. I wish you are fit and healthy. So today we are going to start the topic that is trigonometry. This is the basic part of 11th class. Okay. So in 10th class you read about 6 ratios, 6 basic trigonometric ratios that are sine, cos, tan, sec, cot, cosec. These are the 6 basic ratios of trigonometry. Now what we are going to do, we are going to identify their sign conventions, okay, and quadrant system. As you all know, this is a quadrant. This is first quadrant, second quadrant, third quadrant and fourth quadrant. First quadrant lies between 0 degree to pi by 2 and the second quadrant lies between pi by 2 to pi, and third quadrant lies between pi to 3 pi by 2, and the fourth quadrant lies between 3 pi by 2 to 2 pi. The frequency of each and every trigonometric function shows between 0 to 2 pi. Okay. So in first quadrant all trigonometric functions are positive. That means ki all are positive. All 6 trigonometric ratios are positive. In second quadrant sine and cosec are positive. And in third quadrant tan and cot function is positive, and in fourth quadrant remaining cos and sec function is positive. That means ki all values are positive in first quadrant, sine and cosec are positive in second, and in third tan and cot, and in fourth cos and sec. So if I, for example, sine 120 degree is how we can write this? Sine 90 plus 30, so it becomes cos 30. As this is positive, sine function is positive in second quadrant and 120 degree lies in the second quadrant, so cos 30 degree will be positive, and cos 30 we all know under root 3 upon 2. But for cos function, cos 120 degree is equals to cos 90 plus 30 will be minus sin 30 degree, because cos is not positive in the second quadrant. So what will be the value? Minus 1 upon 2. So this is it, all works. Now we are going to identify the range and domain of all the trigonometric functions through graphical representation. So let's draw some graphs. This is the sine function. This is the graphical representation of a sine function. This starts from 0 and increases onwards and again reaches at the apex at pi by 2. As you know that the maximum value of sine function from this graph is 1 and the minimum value is minus 1. So the value of sine functions lies between 1 to minus 1. That means we can say minus 1 to 1. So the range of sine function is between minus 1 and 1. On this axis we give the values of angles, different angles. Now as you can see, we can give any angle to the sine function. So the domain of this sine function is always real number. That means you can take any real number for the sine function, and its frequency is between 0 to 2 pi. This repeats itself between 0 to 2 pi. So the frequency is 2 pi. Okay. This is the next function, which is y is equals to cos x. So cos x function, its graph is almost similar to the sin x function, but there is a 90 degree phase shift in the cos function. So this starts from 0. At the 0 degree its value is highest, which is 1, and at the 90 degree, which is pi by 2, it has 0 value, and at the pi it has minus 1. So its range is also between minus 1 to 1. So its range of cosine function is minus 1 to 1, and again the domain is all real number, and it shows the frequency in every 2 pi region, so the frequency is also 2 pi. This is the graphical representation of tan function. Now, as you can see, the value of function is 0 at 0 degree and increases onwards. But at pi by 2, it is not defined. Okay, so at pi by 2, 3 pi by 2, and similarly at minus pi by 2, minus 3 pi by 2, tan function does not define. So its range is R. That means its value or the range is R. Any value you can take, but in domain, its domain is also R, but it does not take the values like pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2. So we exclude these values. So we can write is at R minus 2n plus 1 pi by 2, its domain, and its frequency every pi interval it appears again. That's its frequency is pi. The next function is cot x function. Now here it does not define at 0 because cot 0 is not defined, or we can say undefined. So its value is 0 at pi by 2. At its initial value at 0 after 0 is highest, but simultaneously it decreases and reaches at 0 at pi by 2, and again continuously decreases afterwards. And as you can see, it does not define at pi, 2 pi and minus pi. So its domain is R, but we exclude these values. So we can write it as R minus n pi, and you can see its range is R, all real number, and its frequency is also pi. Now this is the sec function. Now as you can see, its value is not defined between 1 and minus 1. Okay, and also its domain is not defined at minus pi by 2, pi by 2 and 3 pi by 2. So its domain is R, but we exclude the value 2n plus 1 pi by 2, and similarly for range we exclude the value between minus 1 and 1. Otherwise its range is R and domain is R, but its frequency is 2 pi as the sine and cos function. And finally, this is the cosec function. Its graph represented as like this. Its range does not define between 1 and minus 1, similarly sec function, and its angles also does not define at pi, 2 pi and minus pi, minus 2 pi. So we excluded all these angles from the domain, and in range, as we can see that the value does not define between 1 and minus 1, so we have excluded this area, and its frequency is similar to the sine and cos function, which is 2 pi. So all these are all the graphical representation of trigonometric functions, and this is the just basic part of trigonometry of 11th class, and we will discuss further in the coming videos. Thank you.